There is one last method I'm going to show you for finding our greatest common factor or greatest common divisor. And then we can use that. There's a second theorem here for finding the least common multiple. To find the greatest common divisor, we're going to use the Euclidean algorithm, and I have the steps for it listed. I'll actually walk you through it. It might seem a little more intimidating if you read the 2 steps, but once you see me work through it, it's not as bad as it initially looks. The second theorem is much more straightforward. It says that if you multiply 2 numbers together, the product of those 2 numbers is going to equal the product of their greatest common divisor times their least common multiple. We're going to use the Euclidean algorithm to find the greatest common divisor between a pair of numbers. Then we're going to use that second theorem to find the LCM. So I'm going to slightly rewrite it. The second theorem, I'm going to solve for the LCM. So we have the LCM is equal to the product of the 2 numbers divided by the greatest common divisor. And again, greatest common divisor, greatest common factor, they're used interchangeably. You've probably heard me use them interchangeably in these videos. So let me start by showing you how the Euclidean algorithm works. I've got a total of 3 examples. For the first one, we're asked to find the greatest common divisor between 3,500 and 550. So the way the Euclidean algorithm works, you're going to divide these. You're going to take 3,500. You always take the larger divided by the smaller. So take 3,500 divided by 550. And when you divide these, you're going to get 6 with a remainder of 200. And to save a little time, I'm not going through the calculator work here. I trust that everybody can find the quotient and remainder for these. If the remainder is 0, you are done. If the remainder is not 0, you're going to repeat the process, but this time you're going to divide that second number, the divisor, by the remainder. So our second step, we're going to take 550 divided by 200. When you do this, you get 2 with a remainder of 150. So we still are not at a remainder of 0, so we need to continue. Once again, I'm going to take the divisor, divide it by the remainder. Here I get 1 with a remainder of 50. We're getting closer, not quite there yet. Repeat the process. Divisor divided by remainder. So 150 divided by 50 is 3 with a remainder of 0. So we are done. The greatest common divisor is going to be the last divisor there. So in this case, it's going to be the 50. So our greatest common divisor is the 50. To find the least common multiple, this is a lot easier. We're going to multiply the 2 numbers together. So 3,500 times 550 and divide that by 50. And again, calculator work, you can verify, but you just divide that out and you're going to get 38,500 for the LCM. So the second part, finding the LCM, is very quick, but I'll go through a couple more examples of this Euclidean algorithm. So here we're asked to find the greatest common divisor between 3,915 and 825. So again, I'm going to divide 3,915 divided by 825. And that gives me 4 with a remainder of 615. I do not have a remainder of 0, so I'm going to take the divisor, divide it by the remainder, and that gives me a 1 with a remainder of 210. So we repeat the process, this time taking 615, divide it by the remainder. So that gives me 2 with a remainder of 195. So you can see each time a remainder is getting smaller. We're not where we need to be yet, though. 210 divided by 195. That's going to give us 1 with a remainder of 15. Then 195 divided by 15 is 13 with a remainder of 0. So we've reached a remainder of 0. Our greatest common divisor is that last divisor. In this case, it's 15. So our greatest common divisor here is 15. To find the least common multiple, you're going to multiply your two original numbers together and then divide by that greatest common divisor. So in this case, our least common multiple is 215,325. And then one last one. We're asked to find the greatest common divisor between 624 and 1044. So the Euclidean algorithm works when you take the larger number divided by the smaller number. So I'm going to do 1044 divided by 624. And that gives me a 1 with a remainder of 420. And then we're going to repeat 624 divided by 420. That's 1 with a remainder of 204. 420 divided by 204 is 2 with a remainder of 12. Then 204 divided by 12 gives us 17 with a remainder of 0. So our greatest common divisor here is 12. The least common multiple, take the two numbers, multiply them together, divide by the greatest common divisor, which is 12, and you'll end up with 54,288. So the Euclidean algorithm, at first it might seem a little unusual or complicated, but hopefully as you've seen these few examples, you can see it's a pretty straightforward process, and it might actually be quicker in some cases than trying to find all of the factors of a number. As always, if you have any questions, please feel free to reach out to me.